Okay, so that was chemical equations. Does anyone have any questions? Yeah, Mr. Maxon, can you repeat all of that? Alright, so welcome to chemical equations. You're first going to start out with some reactants that'll later turn into products. These can range anywhere from a solid, such as copper solid, to a gas, such as hydrogen gas, even to something that is aqueous, such as calcium chloride to aqueous. You can also have a liquid such as H2O, also known as water. Now, in case you're wondering what aqueous means, what it basically means is the chemical could be dissolved in water. Now, along the way, you're going to come across some signs. You may not know what they mean, but don't worry, I'm here to tell you. This sign up here indicates that a reaction is reversible. This sign over here, also sometimes having the word heat in front of it rather than a triangle, means that heat is being added to the equation. And this PT is short for a catalyst, meaning a catalyst is used in the equation. Now, there are some indicators of reactions, sometimes spelled RXN. These can range anywhere from a change of color, adding heat, which is also sometimes known as an explosion, odor emission, or even a change of state. No, not that kind of state. I'm talking about solids, liquids, and gases. One of the most common changes of state is from a liquid to a solid, also known as freezing in many cases. Freezing often happens through a lack of temperature in a liquid, which causes the particles to slow down enough for it to become a solid. The most common example of this is water, also known as H2O, into ice. If you say put your water in the freezer, it could be turned into everyday ice cubes, which can also be used to cool down your water for later. Now, many believe water gets colder, causing it to become ice, but in actuality, cold is not actually a thing. It's just a lack of temperature, or lack of heat, if you will. Now, as you might notice, ice generally melts in a drink. What's going on there is the ice is absorbing the heat from the liquid, and the heat is being released out of said liquid into the ice, causing it to melt, causing the drink to also cool down. Alright, so now it is time to do some experiments. Now what we're going to be doing today is mixing a cup of mercury to my left, also known as Hg, and a cup of bromine on my right, also known as Br. Now, in actuality, when you mix these two, generally they change color from a white to a yellowish when heated. Often it goes into a fluorescent salmon or pink color when it is exposed to an ultraviolet light. As you can see here, that might not be the case. To eagle-eyed viewers, this may look like 2 glasses of water being mixed together, but I can assure you they are not. Now what these two create is a formula known as mercury 1 bromide. Now, as with any chemicals, it is highly, highly recommended you let it nowhere near your face, eyes, skin, or mouth. And as you can see here, this man looks like he is about to drink it. In actuality, this idea is very stupid, and one can imagine this man will die by tomorrow. Okay, so on to the next experiment. What we're going to be doing here is mixing a bottle of zinc, otherwise known as Zn, which has been placed in a bottle of what looks like pepper, with a bottle of copper oxide, which looks like it's in a bottle of garlic, but I can assure you these two are what I'm telling you. Now, when readying for this chemical reaction, I can assure you that all safety precautions have been taken here, and that I will be A-OK by the end of this. As with as very unlike the gentleman in the last experiment who died shortly after. Now what I'm going to be doing here is I'm going to place the bottle of zinc onto this napkin. I can assure you this is still very safe, and as you can see, this is what my zinc looks like. It may look different if you get your own bottle of zinc, but I can assure you what I have here is 100% zinc. Now I'm going to be putting the bottle of copper oxide next to it to show you what they look like. A little side-by-side comparison, if you will. Just a sec, let me get this ready. There you go, some good old-fashioned copper oxide right next to our zinc. Just going to do a quick zoom in on the two so you could get a clear distinction of which one is which, the left being zinc and the right being my copper oxide. Now here one last time is the containers of zinc on the left, which looks like a bottle of pepper, and the bottle of copper oxide on the right, which looks like everyday garlic. Now I'm going to be placing the garlic first, the copper oxide on the napkin first, followed by the zinc. Now what you're witnessing here is a chemical reaction, which you have witnessed in the last one, but I digress. Just sort of layering it on thick there. Yep, there's a lot of zinc. So what you're witnessing here is the formation of two new chemical compounds known as zinc oxide and copper. Just plain copper. Now, as you can see here, it looks like they are one, but I can assure you they are two completely separate compounds here. Now, as with any experiment, it is highly recommended that you do not do this at home, and do this with some form of supervision or another. Now, if you do this, please do not drink, ingest, or place any of what comes out of your experiment on your skin. It is highly recommended, so you won't end up as the gentleman in the last experiment. And thank you very much for listening to Chemical Reactions. I'm sure the other videos on this channel will help you out with anything else you need to know about chemistry.